Welcome to a lesson with Dr. Powell. We're going to look at another example of a graph transformation of a function. Namely, let's look at the function y is equal to absolute value of x, which looks like this. Okay, so, and then how does this change to this over here? Well, think about the absolute value symbol as representing the old function. Now, how do you get to the new y and the new x from the old? Well, notice that the new y is on the outside of the absolute value partition here. And so what we do is we work from the outside of that absolute value to y. So the first thing we do to that absolute value is we multiply by -2. So for y values, so y transformations or vertical transformations, what's happening? First thing is a multiplication by -2 to all the old y values. Then after we multiply by -2 to all the y values, we subtract 3. So we multiply by -2, then we subtract 3. Now let's split up this multiplication by -2 into two different things. Let's think of that as being multiplication by -1 and multiplication by 2. Because visually, we can think about those in a nice way. If you multiply all your y values by -1, think about what happens. Like something here is going to go there, something here is going to go there. It's a reflection across the x-axis. So we could say reflect across the x-axis. Now, what about multiplication by 2? If you multiply all the y values by 2, look what happens. Something here, multiply by 2, something here, multiply by 2. It's stretching it away from the x-axis. So stretch. Now, if you subtract all your y values by 3, what's happening? That means you're shifting down. So it shifts down. So these are y transformations or vertical transformations. What about horizontal transformations? Let's make a list of those. We think about it very similarly. We want to know how to move from the old function, which is represented by the absolute value symbols, to the new x value. It's in here. So what's the process of moving from the entire expression right here, which is right inside of the absolute values, down to that x, just like we moved from outside, from the absolute values outside to y. What was our path? Multiply by -2, then subtract 3. Here, we're going to work from the right inside of the absolute values into the x. So we could even notationally write out -3x plus 1, and think of this as a package to be unraveled. We subtract 1 to get -3x. Let's split this up into just like we did here with multiplication by -1 and a multiplication by 1/3. So if we multiply by -1, we'd get 3x. Multiply by 1/3, we would get x. So notice we subtract 1 for starters, then we multiply by -1, then we multiply by 1/3. That actually gives us exactly what's happening. If all the x values go down by 1, that means you're shifting to the left. So a shift, so the first thing we do is we shift to the left by 1. Next thing we do, we multiply all the x values by -1. What happens? Multiplication by -1 is like a reflection, but this time across the y-axis. So we reflect across the y-axis. Maybe what we should do there is just notation. I just kind of had a thought. Maybe it would be nice if I rewrote that as up and down, kind of so we remembered across the x-axis, across the y-axis. Okay. And then the last thing, we multiply by 1/3. So what happens if we multiply all x values by 1/3? Next value here will move into 1/3 of it, here and 1/3 of it. Everything's being compressed closer to the y-axis. So we compress or shrink, or however we want to say that. Maybe we'll just say compress. Compress by a third. And those are your horizontal transformations. Those are your vertical transformations. And applying them now to your graph, you can see how it changes. So first, let's just kind of walk through those steps of what's going to happen. Okay, so if we multiply, okay, so going through this, first reflect. Now, the order here is important. If we change the order of what we're doing, we'll end up getting a different graph. Just the same way as if you change your order of operations, you get a different algebraic expression. It's the same because the algebra is directly related to the geometry, just perfectly. So order is extremely important. Don't get this out of order as you do it. So there are a few different orders that actually would work, but you would have to change your setup here, just as if you would have to change your setup here. Like we could factor and then multiply, distribute, or this or that. There's different things you can do algebraically. So since there's different ways of doing something algebraically, there's some different ways of doing things geometrically. However, not always are correct algebraically, so not always are correct geometrically either. So just keep that in mind. So this is one of the acceptable ways, and we got it because it was an acceptable way from the algebra. Here for the x, whittling down, here from the y, building the expression to y. Okay, so first thing we do is we reflect across the x-axis, so the graph will reflect down. Next, we stretch it by 2. So stretching would just stretch it down like this. All right. Then the next thing we do is we shift it down by 3. So down stretched by 3 would be down here. So this would be the graph here. It's been reflected, stretched, and shifted down. Now horizontally, let's work through that. The first thing is to shift it to the left 1. So we shift it to the left 1. Okay, the next thing we do is we reflect it across the y-axis. So it would come over here. So right now here, and then we compress by a third. So compressing by a third will move this point in. So everything's being compressed to this. So this point will stay the same, but the rest of these points will shrink in. So this will move to right here, or a third in, I guess, a third in. So like that. This will still come in here. So it's going to be symmetric though. So maybe it's a little bit more. Let's see about that. Just kind of redo that a little bit. So it's going to be more, since it's coming in right here, it's going to be more like, it's going to be symmetric right there. Okay, maybe like steeper, something like that. Okay, so that's going to be our final graph in this particular example. Thanks for watching.